Welcome back to Tech Blazer. Today we dive into the remarkable story of the James Webb Space Telescope. Will it find signs of alien life, early galaxies? We can't wait to find out. So hit that like button, click subscribe, and let's get rolling on the amazing saga of the James Webb. Since the dawn of civilization, humanity has gazed up at the night sky and wondered, what's out there? Seeking to uncover the mysteries of our vast universe, we have launched telescopes into space to be our eyes amongst the stars. Now, the most complex space observatory ever built will fundamentally transform our view of the cosmos. Over 20 years in the making, with contributions from over 10,000 scientists and engineers worldwide, Webb is the largest space telescope ever launched into orbit. 100 times more powerful than the Hubble Space Telescope, Webb is designed to analyze every phase of cosmic history in unparalleled detail. Perched nearly 1 million miles from Earth, Webb's infrared vision can finally reveal parts of the universe hidden from other telescopes. Its epic journey from conception to reality has overcome immense technical challenges, like building an enormous mirror in space, crafting sunshields the size of tennis courts, and unfolding the entire observatory in zero gravity. Now fully operational, Webb is poised to revolutionize our understanding of the universe. How did this incredible telescope make it from dream to reality? What will its discoveries teach us about our cosmic origins? And how will it push the boundaries of human knowledge? This is the story of the engineers, scientists, and dreamers who achieved the seemingly impossible and built the future of space exploration. Our story begins in 1989. With the Hubble Space Telescope proving the value of space-based observation, NASA started exploring the idea of an advanced new telescope to peer deeper into the infrared universe. Infrared light, which is invisible to the human eye, allows viewing extremely distant or old cosmic objects whose visible light has been stretched or obscured over billions of light years. In 2002, the project was named the James Webb Space Telescope, after NASA's influential second administrator. Webb would be an ambitious partnership between NASA, the European Space Agency, and the Canadian Space Agency. But there were monumental engineering obstacles to overcome first. The sunshield was one of the toughest things engineers had to design for Webb. They needed to build a huge folding screen the size of a tennis court that would block light and heat from the sun. This folding screen had to open up perfectly when it was 500,000 miles away from Earth, making a sunshield so big that could still fold up for launch and then unfold so far away was something no one had done before. It was a very difficult challenge. If you enjoy the video, please like and subscribe to Tech Blazer. Now, let's go back to the video. Webb would also need a much larger primary mirror than Hubble to collect the faint infrared light from the early universe. But a 21-foot segmented mirror would be far too large to launch in one piece. It would need to mechanically fold up inside the rocket and then deploy itself in space. The Webb mirror used untested folding technology. Engineers built a lightweight segmented beryllium mirror that could fold for launch. Unfolding the large delicate mirror flawlessly in zero gravity was extremely hard. But the innovative folding mirror was critical for Webb to see distant galaxies. Despite constant budget overruns and delays, by 2021, Webb was deemed ready for launch. On December 25th, the billion-dollar observatory soared into space, the hopes of thousands of scientists riding with it. A month later, Webb arrived at its home, the second Lagrange point a million miles from Earth. Here it underwent its most perilous phase, carefully deploying the entire observatory from its launched configuration. Unfurling sunshields, mirrors, and instruments from their tightly folded launch positions would take 10 painstaking weeks and over 100 individual steps. The deployment sequence was extremely tense. There were so many single-point failures. Over 130 release mechanisms had to work perfectly, with no room for error. The whole team was living on coffee watching each step complete. Incredibly, by mid-January 2022, every parachute, pulley, and actuator had performed flawlessly. Webb's expansive sunshield and giant mirror were finally in place. After 20 years of waiting, engineers' work was complete, and it was time for astronomers to take the wheel. Painstaking mirror alignment and instrument calibration continued for 6 months, preparing Webb for its landmark first images. Finally, in July 2022, the first dazzling views from Webb were revealed. Instantly iconic images of the Carina Nebula, Southern Ring Nebula, Stephan's Quintet, and a landscape of distant galaxies. After so many years supporting Webb, it was incredibly moving to see those first images. We knew Webb's potential, now the world got to see it too. These were scenes more vibrant and detailed than we could have imagined. But Webb was just getting started. Scientists eagerly pointed the observatory deeper into the universe and made discovery after groundbreaking discovery. In August 2022, Webb revealed its first exoplanet atmosphere, detecting signatures of water, clouds, and haze on the gas giant WASP-96b. This was definitive proof that Webb could characterize the atmospheres of planets far beyond our solar system, with implications for the search for signs of life. Another historic find followed just weeks later, when Webb captured an image of the most distant star ever seen. This enormous ancient star, nicknamed Arundel, existed just 900 million years after the Big Bang. Analyzing the star's properties offered an unprecedented glimpse into the earliest star formation after the universe's birth. But the most anticipated discovery came in September 2022 when NASA revealed Webb's first deep field. This composite image stitched together exposures from over 12 hours. Peering through time and space, the image showcased thousands of galaxies as they appeared more than 13 billion years ago, just after the Big Bang. Webb's early feats are only the beginning for NASA's revolutionary eye in the sky. The giant gold mirror steering Webb's vision is over 60 times more sensitive than Hubble's, capturing light from the earliest stars and galaxies that formed after the Big Bang. Webb's 4 science instruments work in unison to analyze infrared light from the cosmos. Its cameras create stunning visible light images. Its spectrographs break light into wavelengths, revealing objects' chemical composition, and its coronagraphs block starlight to enable directly imaging exoplanets and dust clouds. Together, these instruments open a wide infrared window into the previously unseen universe. Scientists controlling Webb are a new generation standing on the shoulders of Hubble pioneers. Now they eagerly peer through Webb's lenses to fill in the missing chapters of cosmic history. What exotic exoplanets will Webb uncover? When exactly did the first galaxies form? How do stars and planets come into being? And could Webb detections even point to signatures of life? The questions Webb may answer are as expansive as the cosmos it observes. With a planned lifetime of 20 years, the James Webb Space Telescope has ample time to revolutionize human understanding of the universe. Its vantage point a million miles from Earth provides a crystal-clear infrared view, free from our atmosphere's interference. From its distant location in outer space, the James Webb Space Telescope will fundamentally alter our understanding of our cosmic origins. Its infrared vision is a powerful time machine, capturing light from the universe's earliest moments and uncovering hidden facets of creation. What Webb reveals may well expand the bounds of known science. The James Webb Space Telescope is a result of hard work by many who solved tough problems. Now it shows us space like never before. Join us in exploring the universe. Remember to like and subscribe for more exciting discoveries.